Hi, this is Adana Wilkie, the Cincinnati State's Physics Department, and today we are going to do a torque equation using angled forces. So I have a problem statement written behind me. It says that you are fixing the fridge. You apply 12 pounds of force on an 18-inch wrench at 30 degrees. What is the torque on the wrench? Well, first thing what we want to do is sketch our wrench. Oh, that's too small. You need to see it. I feel like as I keep drawing this, it gets worse and worse. Sure. Okay, so there's my wrench, and it says I am applying 12 pounds at approximately 30 degrees. So 12 pounds. Okay, and my length is 18 inches. Okay, so next thing that you want to do is draw your moment diagram. So I'm going to get a little precise here and break out the meter stick. And we're going to do about 18 inches of a wrench. Okay, it's a little low because I'm going to do some stuff up here. So, okay, and then I'm going to, you don't have to get really precise, but about 30 degrees, I'm just going to break out the protractor, no biggie. Okay, and once again, just get it approximated. You don't have to have it exact. Okay, it's a bit big. Okay, so I have 12 pounds of force at 30 degrees. Next, what you want to draw is your pivot point. Now, think about a wrench. This is my wrench. And I push it this way or pull it this way. It's going to pivot at the head of the wrench. So that's where my pivot point is going to be. And again, this is an 18-inch wrench. I'm going to go ahead and convert that to feet, which is 1.5 feet. Okay? You can pause the video at any time to catch up if need be. So next, we want to write down a relationship for torque. So you should know that torque equals the force times your arm. Now in this video, we're going to do the arm perpendicular to our force. In the next video that you should watch, we'll do an alternate way to do this and an extension on the problem. But for right now, we're going to do the arm perpendicular. So we have to find our perpendicular arm. What I'm going to do, actually, is get my protractor and put it on my force and label 90 degrees. Okay, so if you see it, that's just a marker for me to, when I put my, will help if I show you, when I put this on here, you want it perpendicular. So that's just a marker for me to start off so that when I travel up my force, I keep it perpendicular. Okay, if you're good at guessing where the perpendicular is, I'm not. I'm more like over here, and it's just not right. You need to make sure that it's perpendicular so your trig works out. Okay, so I'm going to have this perpendicular right here. And then to find my arm, I have to travel up my force till the meter stick or your pencil or your straight edge hits the pivot point. Boop. But if I stop right there, the arrow doesn't continue, and that's crazy out here. You don't know what's out there. So you just extend your force line. Force is a vector, so it can bloop, keep going. Okay, I mean, it doesn't need to be completely straight, but I'm doing this for your purpose. Okay. Label 12 pounds. Okay. Back with the meter stick. Okay. I'm going to travel up my force, up my force, up my force, till it hits my pivot point. Then I'm going to draw the line from the pivot point to my force and label my perpendicular. Now, so you don't get confused with all these lines, you don't know what's going on, this is your wrench, this is your force. Notice they have labels on them. And this one I'm just going to call arm perpendicular. I'm going to put that down there. So we need to find what arm perpendicular is. So you don't need your little dash anymore. Going to say R perpendicular is equal to 30 degrees opposite. We're going to use, opposite, and we have a hypotenuse. We're going to use the sine of theta, which in this case is 30 degrees, times my hypotenuse of 1.5 feet, and that'll equal 0.75 feet. Okay? All right. So now we have a R perpendicular and we have a force. We're just going to continue on with this equation. Force is the 12 pounds times R perpendicular, which is this, and you can even label that on your diagram. Okay? So times 0.75 feet, and that'll equal 9 pound-feet. And theoretically, you could call it foot-pound. I know in your book it actually has it RF instead of FR. So, but multiplication is commutative, so it works out the same way. Okay, so please watch the next video to see an alternate way to do this and an extension on the problem. Thank you.